Hi, my name is Morgan Bradley, and as discussed in previous videos, my molecule is melatonin. So first I'm going to discuss 3 atoms within the molecule, and that would be this oxygen, the carbon-3, and then this carbon-10 that I've labeled. So starting with the oxygen, I'm going to go over the electron arrangement. So I'll just put an arrow right there. So, in order to find the electron arrangement, I use a periodic table, which I have here. And so this would be 1s2, 2s2, and then it's 2p4. Another way of writing this would also be doing helium, because that's the noble gas, 2s2, 2p4. So that's the electron arrangement of oxygen. So next is the electron geometry, which I like to go over. So oxygen has 2 lone pairs, so this would be tetrahedral. This is tetrahedral electron molecularity. And next would be the electron geometry. The next would be electron molecular geometry, and that would be, since this is 2 lone pairs, they go up above, and this would be bent molecular geometry. So that's all for the oxygen. So next would be this carbon. So this carbon, the electron arrangement would be 1s2, 2s2, and then there's only the second and the 2p, so it'd be 2p2. It could also be written helium, 2s2, 2p2. Since helium is also the noble gas, that's before that. So the electron geometry, which I like to say, would be a trigonal planar, because there are only 3 bonds to it. And then that would be the same as the molecular geometry too, since there are no lone pairs. So trigonal planar again. And then lastly is the carbon-10. So since they're both carbons, it would also have the same electron arrangement. I'll write that over here. So it's 1s2, 2s2, 2p2, or helium, 2s2, 2p2. And then this one has 4 bonds, and no lone pairs, so both the electron geometry and the molecular geometry would be tetrahedral. So the next thing that will be discussed is the polarity overall for melatonin. So in order to do this, you have to use the carbons and the different polar functional groups. So first I have to figure out what the polar functional groups are. And as you can see, there are 1, 2, 3, 4, 5 functional groups in melatonin. But only 3 of them are polar, and those would be the ether, the secondary amine, and the amide are all polar. The aromatic ring and the alkene are nonpolar because they're all just carbons and hydrogens. So I have 13 carbons, so I'll do this down here. So you have 13 carbons, and then you divide that by the 3 polar functional groups. And this ended up being, I did the calculation before, and it ended up being like 4.3 or something like that. And so we learned in class that 4.3 means it's slightly polar. So write that. So since it's slightly polar, my assumption would be that since water is polar and this is slightly polar, I would assume that it would be kind of soluble in water, but it wouldn't be the best solubility in water. And that's due to knowing that like polarities dissolve in like polarities. So if this was completely polar, I would assume that yes, it would dissolve in water, but since it's only slightly, I wouldn't think that it would dissolve very well in water. And based on my research, I found one website that said that so it says that 0.1 milligrams per milliliter of melatonin dissolves in water. So as you can see, it doesn't dissolve very well in water. And other websites that I looked at didn't have exact numbers for this, but it did say that it didn't dissolve very well. The solubility isn't very good in water, but it can dissolve some. However, I found another website that said that 50 milligrams per milliliter of melatonin dissolved in ethanol. So that means that melatonin is actually has better solubility in ethanol than it does in water. So it must have better, more like polarity to ethanol than it does in water. So these are the geometries and electron arrangements of the oxygen and the carbons. And then this is how you find the polarity and how I decided if it was soluble or not. Thank you.